Welcome to the Introduction to Geographic Information Systems and Science lecture series developed by the Quinney College of Natural Resources at Utah State University. Discussion topics for this lecture include basic map elements, cartography, map types, and scale. When you're using a GIS to develop a map, there's certain objects or elements that your map should contain to aid in the understanding of your map. Some of these elements include a legend, a scale, north arrow, a title that's descriptive but not wordy, the date your map was created or updated, and the author or organization in the event that the user would like to contact you. In this example, you can see a well-developed map with a title, an easy-to-read legend, a north arrow, data source, author, projection information allowing the user to understand what projection or coordinate system the data is displayed in, and several inset maps along with a scale bar. All of these elements put together help develop a more usable and readable map such that your audience has an easier time understanding the point you're trying to get across. One of the most basic and useful elements of GIS is being able to use the art and science of cartography to display information about the natural and social features of the Earth. Early cartography showed that humans used their best judgment to display the world they understood. Looking at some other maps, every map that's created has a number of unique features. Some of the unique features presented on this map, if you look closely, are oceans, rivers, cities and lands. Note that Babylon is the centric feature, rough distances, and also mountains. So while this map isn't something that we generally understand or would think of as a map, maps have many different ways of being displayed and can contain and display many different types of information. Much early cartography was heavily influenced by religion. Religion-centric maps portrayed the popular and dominant beliefs of the region at the time they were used, and they were very much used to enforce those beliefs. Note that in this early 1472 AD map that Jerusalem is the center of the map. East is on top, not north, and there's three major land masses and an ocean displayed. If we take that map and you note that we can rotate it, what you actually see is that there's a cross in the middle, but when you rotate it north up, Asia, Africa, and Europe generally fall in the areas that we understand them today. Other early cartography included nautical charts that identified critical ocean currents and swells. Many times these maps were read and then left behind for others to use. In our context, this may not qualify as a map as we know it, but to the users there were known features and it displayed information for critical navigation. Again, in this nautical chart from 1554 AD, you can see that major routes are defined, but if you really look closely, there are issues with scale and direction. Some basic concepts of cartography are that maps were meant to transmit information and knowledge and facilitate travel. We generally find that there are two types of maps. There's a general purpose or a formal map that identifies location and navigation, or what we call a thematic or transitory map that is used for visual display and analyzing information. Maps are truly abstractions of reality and can contain distortions from, among other things, scale, projection, and symbology. Thus, cartography really is both an art and a science because it takes a very good cartographer with creative abilities to come up with a good map that transmits information readily. So talking about the map types, we can see a formal map here. Many of you have seen a formal map if you've ever looked at a map on a piece of paper. So discussing the types of maps, here we see a formal map displaying location. Some features of this map are location, distance, orientation, reference, and known features. Speaking of navigation, in the terms of moving from one place to another, humans often can use a visual map much easier than they can use written directions. For example, navigating from Logan, Utah to Salt Lake City International Airport, we have a series of at least 12 steps. If we take that and using Google Maps, type in the addresses, it's quite easy to understand the route we're supposed to take. Humans have a much easier time understanding this visual image than the previous slide that showed the written word. Transitory or thematic maps present a graphical theme describing one or several topics of interest. In this case, you can see a 1996 population density map of the southern United States. Another example of a thematic map is this soil moisture map of the United States. Thematic maps often have a base map that, in this case, our base map includes the counties and the state boundaries for the United States. The producer generally includes only the amount of information necessary to convey the map message. Too much information can cause confusion and difficulty reading the map. Some additional examples shown here are of qualitative categorical data. We can show the lower 48 United States as a single symbol, or we can break them up by colors, or we can start overlaying different types of numerical data, in this case 1990 US population and 1990 US population shown as a graduated symbol. Different types of maps showing similar data but using different methods. Here's several other map examples of Asheville, North Carolina. While we're looking at these, consider whether they're general or thematic, qualitative, quantitative, or perhaps both. As you can see in this slide, we have on the left a map of Asheville, North Carolina showing basic geographic features along with elevation information and transportation networks. On the right, we have some thematic data showing education within and around Asheville, North Carolina. In this example, the map on the left is showing some basic natural hazards. Some historic information has been plotted here showing tropical depressions and tropical storms, and also tornadoes that have touched down over. On the right, we can see a land cover map showing land cover in and around Asheville, North Carolina. Note that these maps have a scale bar, legend, title, a data source, and north arrow. As you begin using GIS to display and understand data, you need to understand the basic cartographic process. You need to think about what the distribution of the phenomena or data may look like, or how the best method would be to display that information. Decide on the purpose of the map and the intended audience. Step 3, collect the data that are appropriate for the purpose of the map. 4, design and construct the map using the correct cartographic principles. And finally, determine if the map reader understands the map. This is where having someone evaluate and critique your work comes in. Keep in mind that information display is critical on all map types. There are several different major quantitative cartographic techniques that can be used to display information. These include Choropleth, Isopleth, proportional symbol, flow maps, and cartograms. Choropleth maps, from the Greek terms choros and pleth, or place and value, are often used when data occur within well-defined units and data are numeric interval data. Choropleth maps are maps that are used to display thematic data in which areas are distinctly colored or shaded to represent some value. Choropleth maps are usually derived from values describing the attributes and are generally non-overlapping polygons. Here's an example of a Choropleth map using a datasymmetric process showing Utah population density in the year 2000. Now what's unique about this map is that the author has taken a number of different types of data. Rather than simply displaying the standard population density data, as you can see in the middle of the map, per county, he's taken this information and looked at the areas where people are most likely to occur, so where human settlements are. He's taken out and excluded water bodies, elevation, public lands, and he's completed a composite that is subtracted and then shown with the population density displayed in each polygon. Next type of map is an isopleth map. Isopleth maps are used to visualize phenomena that are usually conceptualized as fields and measured on interval or ratio scales. Some related terms that you might know when you're working with isopleth maps are isolines and isotherms. Some examples of isopleth maps here. On your left you can see an outbreak of the H1N1 in 2009. On the right you can see mean annual precipitation displayed on isolines. Proportional symbol maps are used to represent proportions of a whole, generally utilized to display point data within some larger area. Often this method is used for population or percentage of population, employment, education, or other economic type data.